All right, class, here we go. I'm going to start off with this pulse width modulation correlated to angular velocity. So we have this equation right here. This is what's important. And then we have a raw count equation. That's the y is equal to 8x. And on this one, this is y is equal to 1.8405 natural log of x minus 10.156. So we want to use these to predict our angular velocity for a couple of scenarios. One will be for the pulse width, and then the other one will be for the raw count. So that's we're going to use this data set here. Okay. So I am just going to go to my iPad here. And on this iPad, I am going to talk to you about these equations. So the first equation here is going to be y equals to 1.8405 natural log of x. Let me see. Oh, let me use math. So y is equal to 1.8405 natural log of x minus 10.156, where the y value is just going to be our angular velocity. For the equation above, and our x value, and let me see if I can draw that a little clearer here. The x value is going to be our, what is that? Pulse width modulation. Okay. So we know what those variables are. If we're looking for the angular velocity and we know the pulse width modulation that we want to utilize, then we can just use this to produce that. The other equation is going to be, and I'll just insert a math, y is equal to 8x. And so now that we have that, in this particular case, y happens to be equal to the pulse width modulation, and x is going to be the raw count. So what I'm going to do is I'm going to derive an equation which will utilize the this equation to connect the raw count to the angular velocity up here. So essentially the y in this case, and I probably should label it something else, something like y prime, and I'll make this x prime. So I didn't do that in my equation. So let me see. All right, there we go. So I'm going to use those in that equation. So we know that y prime is just equal to x. Y prime is just equal to x. So since y prime is equal to x, we can write the following. we can put in y prime into this equation because it's x, so that means we're going to have an equation that looks like this. Y equals to 1.8405 natural log of 8x prime minus 10.15 0.156. So now in this particular case, we have a relationship between our angular velocity goodness, and our raw count. Okay, so with these equations, we're going to predict. So I can just say real quick which two equations we're going to use. We're going to use this equation to predict the raw count, the one right above it. And up here, we're going to use the pulse width modulation to predict the angular velocity. Hopefully that's clear.